Hey everybody, this is Larry. This is day 15 of the Leetcode Daily Challenge, and also this is going to be a weekly one later. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. 1751, maximum number of events that can be attended to. So some of you let me know, let's say that apparently I hit a 1200 day streak, which is kind of a round number, I guess. So yay, go me. But I don't know. I mean, yeah, so let's keep it going, I suppose. Yeah, okay, let's see. Maximum number of events that can be attended to is a hard problem. So you're given an array of events where events of I is start and value. Okay. You can also given an integer k, which represents the max number of events you can attend. And one at a time, you must attend the entire event, so you cannot do. Okay, so this is dynamic programming, but kind of tricky, to be honest. I think it took me a while to kind of. I mean, I think and maybe this is not true. It depends on who you are, right? Some people are strong at certain things, and some people are weaker at certain things. But for me, I feel like this is one of those problems where, like, the observation and maybe even the idea is pretty okay, but the implementation can be tricky and especially if you're not careful, which I haven't been lately. The idea here is, and I'm going to draw. I'm going to bring up my paintbrush if I could find it, and also random ladder. Where did my pen go? Oh, there it is. All right. Right. Let me put it on screen. That would also be helpful, right? All right, so yeah, so basically the idea is that, all right, visually, wrong button. Visually, basically, you look at what is this? You look at a number line or a timeline, I guess, right? You have a timeline, and you have basically some number of segments that may or may not overlap, and of course these have some value, v sub 1, v sub 2, or whatever, right? And you're trying to basically maximize this, right? And the idea here is dynamic programming, though maybe not as straightforward as some of the ones that you have done, is that basically there are two types of events, right? There's the beginning event and an ending event for every segment. So, and then now it's about defining what to do at the beginning and what at the end. Well, at the beginning, because in a way there's no memory with respect to this particular segment, it doesn't matter. And this is kind of actually one of the criteria of dynamic programming in general, this idea of memoryless, though it doesn't really get brought up that much, depending, I mean, or maybe it's just often more intuitive in the sense that it is, how do you say? Like, in the sense that people talk about states, and in terms of states, the idea of memoryless is kind of, very intuitive, or, as intuitive as dynamic programming can be, say, right? But in this case, that's still the case, even though the states are not as concrete and doesn't need to be as concrete as the other ones. And what I mean by that is that, I can't drew this all the way to the left, so let me undo this real quickly. Let me use another color. Let's just look at this V3 one, right? Let's say, you have the beginning and the end, right? And the idea here at the beginning is that, well, we don't care about what happened before, right? In the sense that I don't care if you give me 10 events that's worth 100 or 5 events that's worth 100, or I don't even care which events, as long as you give me the maximum value. And in that sort of way, it is greedy, and therefore that's all you have to do, right? And what does this mean? That means that if you attend here, if you have a way to kind of get all the best events, then, or all the events in general, my pen didn't come. Okay, yeah. That means that you want to take the best and the max, because this is just sort of the greedy part of the optimality type thing with dynamic programming. As long as you kind of get the max, then yeah. What do you do with the max? Well, that means that at the end of here, we have at the end of using v3, we might have a possible new max, because then here, maybe there's some max, and then now this is some max plus v3, right? It may not be a new max, but it is a new max to consider, or a new point to consider. And that's basically the core idea. And once you get that, the implementation could still be a little bit tricky, because you still have to choose some data structure, or at least it's not as if you do a lot of states and stuff like that, it's not as quite that kind of dynamic programming. So it may be a little bit tricky in the sense that it's something new, if nothing else, if you haven't done it before anyway. Well, I guess, okay, fine. Anything that you haven't done before is new, but yeah. So, okay. So for me, now I want to break it down to two types of defense then, right? So for start and re in events, I'm going to relabel this ye. Though maybe that's just terrible, but because I want to use to bring defense. And then, as we said, the two type of defense. So we want to do a start event. So type start. I guess a value, it doesn't really matter. I think it doesn't matter that much as long as we keep an index, right? So that we can just reference it. I don't know that I need to use v right now, right? And then defense, and then the other one, which is n and also index, I suppose. I don't know. I don't know if I need these, to be honest. I haven't really thought, it through, but yeah. And these are just enums that, I mean, it's kind of an awkward way to do. It's kind of an awkward way to do enums, I understand, but this is just for teaching purposes and stuff like this. So forgive me a little bit. But yeah, and then now I'm a little bit off here. Because this is not quite, I have to think about something for a second, right? Which is that, is this inclusive or exclusive? And we have to think about what that means for the bounds. For starting, I always just do inclusive because without loss of generality, it just doesn't change any, or like that's the way you would do it. So S is inclusive, and then E. So the way I think about these, whether it's inclusive or exclusive, is what happens when we have two line segments that are against each other, right? Let's say they have the same thing, then what happens? And here, it depends on the problem, of course. Here it seems like I think the same day thing is a little bit weird, but nonetheless. Okay, so this is what. Yeah, so basically this starts at 3 and this ends at 2. So that means that inclusive should be okay, because that means that we don't parse this yet, right? Because basically what happens when you have, when S is equal to another one's E, and basically we want to process the starts first, and you don't have to, but in this case, thinking through it, we want to process the starts first so that they don't overlap. So in that case, inclusive should be okay, right? And by then, I mean that, otherwise you might have to, oops, well, I don't know what I pressed, E plus 1 or something like this, but here we don't. And then now we sort, and I kind of skipped over a little bit, but all this matters, right? The sorting is sorting by tuple, and what I mean by that is that it sorts from the first element, and the first element is the time, and then the second element, which is the enum, which I know that I hand waved a little bit about the enum, but that means that if 2 points are at the same place, it will do the start first and then the end second, right? So you have to be careful about that. There are other ways you can also handle this as well. Sometimes I do it to make it even more clear that you want to do the start first and then end second and so forth. It really depends on the problem. This problem, maybe I don't want to, or I'm not doing anyway. There's another way that you can think about writing this, and maybe we'll I'm not going to do it for this problem, but I'll give you a little bit of hint if you want to explore that a little bit. But another way of writing it, which for some problems may be better, and maybe even for this one, I don't know. And maybe I have to, is that you can have something like basically mix defense, a hash table of an array or list, and then here you can have something like events. Yeah, or you could even do it two ways, right? You could do it in a lot of ways, but then you could do it like this, right? And then you could sort it inside that and stuff like that. It really depends on the problem, so you may want to explore that a little bit. All right, so now after we sort it, then we have for x or t, I guess, for the timeline. We have to okay, fine, x for the timeline, t for the type, and then index for the index in defense. And then we want to get max so far is equal to 0. And in theory, you could do a best, but I think max so far would already encompass that. And basically here, I don't know. I mean, I'm trying to think whether I'm skipping a step or not. I mean, I think I am a little bit, but it's not that much of a stretch. But okay, fine. Let's write this the slightly inefficient way first, and then we'll go over it. So now we have best, which we will return, and then like current something, right? As you go to a set maybe, or a bag, or I don't know. Let's just do an array, and then here. Yeah, so now given the start event, we go, okay, so what is the current best? Well, current best is equal to the max of current, right? So that means that at I think I wrote this a little bit awkwardly. There are a couple of ways you can write this. That's why I'm like a little bit confused about what's the best way for teaching. Because the other way that you can also write this is with a heap. Actually, I just realized you use it with a heap and then almost like a priority queue. Maybe that's a better way of phrasing it. Yeah, let's do it that way. Actually, yeah, let's do it that way. Because I think maybe that makes more sense. I mean. A lot of this is kind of equivalent, to be honest, the way that I was going to write it, but yeah. So then now, right? Now, okay, we get an event, and now I have to write this a little bit differently, right? Wow. Heap pop of events. We have the xt and in. Right, and basically now we're saying, okay, what is the best that we've seen so far? So best we've seen so far is max of the things we've seen so far, and then we have so that we want to queue up when does this event happen? This event happens at the ending, right? The ending is just ye of index of 2, which is really of 1, sorry, right? Because that's the end day given the index, and I guess maybe you could have also put it in here as well. Maybe that's fine. But I'll just keep it this way. Yeah, so that's the new x n, and then the index is just index, right? The way that I'm writing this is very awkward because I'm trying to do it in an explanation way, but yeah, maybe we can just add another thing. Right? Maybe that's a little bit, I don't know. And then basically, yeah. So I'm like writing this in a way different than I would have write it naturally. That's why I'm like a little bit confused about myself. Okay, I think this is right. It's just that this does nothing for a start. That's why I'm a little bit confused. That's why. Okay. So yeah. Okay, yeah. So then now this is the max of current, which is the max of all the things that we've seen before, plus e of index of 2, which is the rate or the value of that thing, right? And that's pretty much yeah, I think I have to, if this is a start type, then this is what we do. Oops, what to? If this is an end type, then now we get to update current, right? We go current dot append v, right? Because now this v is being able to be unlocked for future future x's. So that's basically the idea, and this will work eventually, right? Oh, I reuse ye here, and all kind of messiness. Larry. Well, at least it works for these two. So let's see why it doesn't work with this. Oh, did I miss something? Why can you only pick 3 friends? Oh, there's a K. Wow, I might have totally solved the wrong problem. Oh, huh. I totally solved the wrong. I missed the K part, to be honest. Sorry, friends. So now I have to rethink it a little bit. So okay. If there was no K, this would be basically this would be it, and then I was going to say something like and then you make an observation based on the fact that current would always be like max so far, and so then now at the end you just kind of max so far is equal to max of v max so far, and this, because this is like monotonically increasing that you can see, right? So yeah, so this would be it if there's no K. I actually totally missed that K, huh? Whoops. It's a good thing that there's an example. But in theory, if there's no K, then, you know, this would be it. And this would be very straightforward and typical, right? Now we have to think about, and this is n log n, so that's why I didn't even look at the constraints, because for reasonable values of n log n is going to be fast enough for competitive and stuff. Okay, so now we have to think about K. That is funky. I think the key thing to note is that there's a very sneaky constraint here where K times n is less than 10 to the 6, which, to be honest, is basically inviting you to do some K times n type algorithm. So let's do that. Yeah, but now I have to kind of recalibrate my head for a second, so apologies. Though, I mean, I hope that you learned something here, right? Like, this isn't totally full, right? But I did kind of I just misread this one. I mean, I don't know, I just didn't see the K until it was too late. Yeah, so this is the thing. Okay, so how do we do K? So K, I mean, the easy way to think about it is, you know, just do the same thing, but yeah, just do the same thing, but with another dimension on K, right? So here, this is so messy. Yeah, maybe this can be K then, right? This would be the current K. Now, is that true? Let me think about this for a second. Yeah, that would be the current like K usage, right? So we use 1, and then we kind of parse it all in there. And then now, instead of max so far, we're just going to have a max so far times k, or maybe k plus 1 just to be better precise. Yeah, I mean, I think this is just a modification of this one, so I guess we didn't really waste anything, but it is very awkward for sure. I'm just putting none because I feel like this, we don't need to use it here. But the idea is that, okay, so everything I said is still relevant, even though it's very awkward maybe. But yeah, so then here, instead, now we do a for loop, right? Which is for I in range of k. Yeah, or something like this. Let me think about this for a second. Sorry, I didn't see the case. I have to think about it. Retool. But the idea here is just that I'm trying to think whether I could do it. We don't actually need to do it like this, or in the sense that I was thinking maybe you could, you know, but yeah, maybe you have something like new max is equal to dot, right, and then now for this, now max so far of, well, 0 doesn't make sense, but I plus 1 is equal to max so far. Oh, whoops, this is not right. Whoops. I mean, new max is equal to this of I plus uv of index of 2. And then now we just put this here, right? And then max so far, this one is just we do it per element. So I guess technically you could start from this one, right? Something like this, right? And then now we can return the max of the max so far. Oops. This is kind of a hard one if you do it. I mean, or it's also like, well, I don't know. I think it's easy to miss this. If you're not looking at the constraints carefully, you could definitely miss this and you just be wasting a lot of time. I, of course, do the easier thing and just miss k altogether. So I don't know, I missed like 2 variables or 2 of these constraints. So yeah. Yeah, let's give it a submit. Hopefully that doesn't time out. Looks okay. 12:01. Did they change this UI a little bit? It looks a little bit different. What did I do last time? Yeah, I guess I did the same thing. Kind of. I don't know what I did, but I went over what. So what is the complexity here, right? Well, there's a heap, and what happens with this heap? For n events, there's going to be one push. Well, this is a heapify, I guess. But there's one pop and one push for each event. So there's going to be n log n, or 2 times n log n, or even 4 times n log n. Doesn't matter, right? It's n log n. Well, all right. Let me step back for a second. Sorry, because I think I'm confusing the way I'm going to say it. But yeah, so there's O of n events, or 2 times n events, which is O of n, right? Because for each event, there's going to be a push and a pop. And maybe twice, say, right? One for the start, one for the end, and then so now we do it 4 times. So 4 times n, which is O of n, right? So this is the number of iterations. Each iteration, we do at least 1 log n operation, and then 1 O of k operation, both here or here, one of these two. So this is so each iteration is O of log n plus k. So then total time is O of n log n plus n times k, right? And space hopefully should be easy to see. This is O of k, this is O of n, but each item, each of the event item, we allocate O of k space, which in theory can all be concurrent. So total space is O of n times k. And that's pretty much all I have for this one. Hopefully I didn't waste too much time. I just misread it complete. I mean, I misread I just missed one of the variables, so I don't know. But yeah, that's all I have for this one. Have a great weekend, everybody. Stay good, stay healthy, take good mental health. I'll see y'all later. Take care. Bye bye.